Hello, everyone. My name is Chip Zoller. I'm a technical product manager here at Nirmata, but I'm also a Kyverno maintainer and have been for a little while. I'm going to walk you through some of the technical details of Kyverno. I'm not going to get super deep, but I'm going to give you a good lay of the land so that you're aware of how it works, what's out there, how it can work for you. As mentioned, please stop us. Please stop me if you have additional questions and you want to dive into things. If we need to schedule any follow-ups for any level of depth that you want to go to, we can get down to code and byte level if you need. So starting with the Kyverno architecture, Kyverno, as many of you may know, is an admission controller. It runs as an admission controller in the cluster. And an admission controller is a Kubernetes standard concept, which allows the API server to send select resources down to some other application that's in the cluster for two primary cases. One of them is to validate them. Here's a resource, yes or no, is it allowed or not? That's where most admission controllers begin and end. That's not so for Kyverno. The other one is to mutate things. That is to change resources transparently. Here's a resource. Whatever I get back is the changed version of that resource. That's what I'll go with when I persist it down to etcd. Kyverno has both of these and a lot more. But those are the two main capabilities of an admission controller, and Kyverno runs as both of those inside of a cluster. So when it receives those API requests, it can do things like validate them, and it can do that in either a blocking mode, as in don't prevent it to run, or just allow it, but tell you about it in a policy report, which we call audit mode. And I'll show what that means and what that looks like in just a little bit later. It also has the ability to mutate, but it also has several new capabilities or different capabilities that you won't find in other policy engines, one of which allows you to generate resources. That is to create new Kubernetes resources of any type, of any configuration, based upon a policy that you define and install in the cluster. You can also do things like check your OCI container images for things like signatures and attestations. You can do that embedded into Kyverno. There's no additional things that you add on. There's no nuts and bolts. And again, you do it just by everything is controlled by adding a policy. And I'll show what that looks like and kind of how they work. So you can do things like verify images. And we just released version 1.9 of Kyverno yesterday. And one of the new capabilities that brings is you can clean up resources as well. So stale resources in your cluster that look like this, of this number, Kyverno can go and remove those resources, again, based on a policy if you so choose. So I'm not going to explode into getting all the nuts and bolts of this slide right here. It's got a number of components, but you see the main component here is the webhook when it's running in the cluster. The webhook it'll shunt those requests to the engine, and then we'll manage a bunch of resources that are out here. But a couple things to understand top of mind. So from an overall perspective, Kyverno can run inside of the cluster and as an admission controller. It does have an external CLI that allows you to run in a pipeline and kind of show what that means. And being able to do things at runtime inside of the cluster, it can all be done through Kyverno. So here's a basic anatomy just from a mental model picture of a Kyverno policy. So a Kyverno policy is a standard Kubernetes custom resource. And a policy can be either cluster scoped or namespace scoped. One policy has one or multiple rules. Each rule has a simple match block. It may optionally have an exclude block, but a match block states all of the possibilities that are here. You can use any of these. You can use all of these to define the scope of the resource that you want to apply policy to. And as you can see, there are a lot of different options. A couple things to point out that you won't find in other policy engines that make Kyverno even more powerful are things like cluster roles and roles. This isn't normally included in the API server. Kyverno will go and look these up so that you can easily match on them without having to write any code at all, in addition to these other things. Inside of that rule, you also declare what type of behavior you want. If it's validation, you're going to validate a resource. That's the yes or no behavior. If it's a mutate rule, that means you're going to change the resource. If it's a generate, that means you're going to ask Kyverno to create some new resource for you based upon a definition that you provide. And if it's a verify images, that means that you're going to ask Kyverno to go and check the OCI registry for things like signatures and attestations on an image before it's allowed to be pulled in or admitted into the cluster. So that's a high level of what a Kyverno policy consists of. So here's an example of what a Kyverno policy looks like. And this looks extremely simple. And you might be thinking that, well, this is nice, but there's got to be some other components. There's not. This is a fully functional policy. A cluster policy applies to the entire cluster with nothing else that you need to do. Audit mode simply means we're going to allow this through no matter what, but we want to know about it. Background, it's going to check all of the resources that were already in the cluster before you created this policy so that this policy applies to them as well. And some basic things, there's a match block. We're going to look at all pods and we're going to validate. So back on when I described what the rules are, this is a yes or no decision. Validation is going to check and make sure that your label called app.kubernetes.io/name, which is an extremely common label that gets applied, has some value. And if it doesn't, it's going to tell you with the return message right there. So this is a fully functional policy that you can install right now. It will not block anything. And it'll tell you in a policy report all of the things that do not have that label. All of the policies in Kyverno are written as standard YAML. There's no surprise block scalar, and then you have some esoteric DSL or some other programming language that's stuffed in there. All of the things that Kyverno does, we shift away the burden from you, and we put the burden on our shoulders, which allows you to write policies as simple as this that are quickly and easily effective. We handle all the difficulties on our side. And by the way, this is a very simple example of a policy, but there are tons of examples of far more complex policies that Kyverno is able to express just as simply. And down there at the bottom, we have 265 policies, and that number goes up almost every week, that you can use in your environment, not only to solve your use cases, but if you wanted to use those as teaching aids, you can take a look at all of the policies that we have and see the types of complex use cases that they're able to solve. So just a little bit better of a commit, build, deploy, run graphic of where Kyverno fits in. At the commit stage, you can check that those manifests that are being checked in, before they get checked in, that they conform to the policies that you want. And by the way, they're the same policies that you install in a cluster. So it's not like that you have to write a bespoke set of checks. Whatever you have in the cluster, you can apply in the pipeline to know consistently what the result's going to be before you actually attempt it. So that's in the commit phase. Obviously, signing your own container images is an extremely important initiative. Kyverno can help on the verification stage. All the way through the run, whatever the policies that you have that are checking those things at the beginning of your pipeline are the same policies that get deployed and ensure that runtime things, even if they happen to skirt through the CI pipeline, get enforced and the same behavior is applied. From the use case perspective, there are a ton that span from the CI/CD pipeline all the way to running inside of a cluster. And I'm not gonna drain this entire slide, but you can see just some examples, and there are others. There are some examples, but from the CI/CD pipeline, you want to be able to check in your manifests, but before you accept manifests, you want to be able to apply whatever the same checks that are going on in your cluster in your pipeline so that they don't make it to the cluster if they're not okay. And also, if you wanted to change manifests so that you can store them in Git, of course, you can do that as well. But Kyverno has plumbing that goes all the way through this. So the CLI can be used in the CI/CD pipeline. You can do things like whenever a PR is open, I'm not sure if you use GitHub or GitLab or something else for on-prem, you can plumb that up to it and apply the policies that are the same policies that are in the cluster and see what would happen. And also do things like checking that the resources that you expect to allow, you can declare in a specific test manifest, hey, these should be allowed. Let's make sure with the next upgraded version that they continue to be allowed. And then running all the way, of course, into the cluster, talked about background or admission control, but also background scans, which I'll get into in just a little bit here. So, the quintessential use cases for any admission controller are things like pod security. And if you're not using pod security today in any way, shape, or form, this is a great and easy way to get started with that everybody should be doing. Doesn't matter whether you use Kyverno or whether you use something else. you need to be enforcing pod security. Kubernetes is not secure by default, despite what some may believe. So ensuring things like pods don't run as root, hosts or pods don't attempt to mount namespaces, they don't run with GID 0, all these types of things you need to be enforcing. But from the security perspective, and this is kind of the main angle that people think about when they think about admission controllers, but Kyverno is so much more capable than just security. But you can see some of the use cases around there. Image signing and verification. As part of your software supply chain, you not only want to ensure that in your authoring pipelines that things are working properly, but you want to make sure before they even get pulled into a cluster that they get validated. So end to end, that should work. And things like reports, so that security teams can understand what's going on from an auditing and just simple visibility perspective. What's going on? What was allowed? Why was it allowed? Things like that. Kyverno has a lot of use cases for operations teams. So one of the things that makes Kyverno extremely popular for platform and ops teams are these abilities for doing things like namespaces as a service. You create a namespace with a bunch of other resources that are in it. Kyverno can generate all of those resources for you based on policy defined, as a manifest that you store and get. So there's no more having to go and run bash scripts and spit out resource quotas and limit ranges and all that. You can define all of that simply in a YAML policy, install it in the cluster, version it in Git, and Kyverno will go and operate on that and generate all those things. A lot of other things down there. I could give you a sermon on each one of these. We probably have blogs on almost all of them at this point in time. Some other things that are super nice for operations teams. Being able to do things like inject certificates as volumes, being able to inject sidecars, being able to copy and then sync config maps and secrets across the entire cluster. And as I mentioned on the previous one in 1.9, we've got the new cleanup ability. So you can remove stale resources that are in your cluster on a policy definition. On the cost governance side, those that are running in clouds like you are with EKS, somebody creates a load balancer, spins up an ALB, that's going to cost you money. You probably want to make sure that type of attempt, even though somebody has ability to create services, you carefully gate because that has cost ramifications. So Kyverno is able to help there as well with being able to set things like those quotas when you generate namespaces, being able to watch for those things like load balancers that are going to have cost ramifications, and setting basic things like requests and limits, both from a validation and a mutation perspective, and a lot more. But the cost is a domain that has to be considered, especially when you run in the cloud, as I'm sure you all understand and appreciate. These are just, again, a snippet of the types of use cases that Kyverno can address in a number of its capabilities that are out there. So I'm not going to drain all of this, but again, want to emphasize that Kyverno is a tool that's just as capable for security and governance as it is for platform and ops teams, because it allows for automation. That's not something that other policy engines really do. So all of these capabilities come together and enable not only some really powerful capabilities, but you can hand things off from one policy and rule to another so that you get these high level use cases that you can solve without involving other tools. And that's a big win for Kubernetes, because doesn't matter what scale you use, you have to use multiple tools. But if you can use fewer tools rather than more tools, that's a win, because that's more stuff to reason about, or those are fewer things to reason about, fewer things to break and maintain, all of that type of stuff. So what we often see is that people start using Kyverno for things like basic validation use cases like pod security that I described. But then when they realize the full power of it, they start using more and more and more rule types. And then they start to realize that I don't need these 3 other tools to do what Kyverno can do. That simplifies your operations. That makes, and being able to control that behavior all as policy as code that you can store in version and deploy as just another YAML manifest, is extremely powerful, and also it makes lives for operators a lot easier. Okay, so multi-tenancy, just to touch on this really quickly, if you're using multi-tenancy, and that could be that's not necessarily Coke versus Pepsi, that could be your engineering, your HR, your prod A, prod B, whatever the case. Kubernetes has several constructs that can work with you, but very often you have to either provide some bespoke automation for those, like bash scripts or something else. There are some other tools that are out there, but depending on what you need, you have to create these, or you have to figure out how that happens. Policies can be used to do things like generate those per namespace defaults, whether they're like resource quotas or limit ranges, and also enforce things like multi-tenant configurations through making sure that a network policy is created, making sure that they exist, storage classes, all sorts of things like this. So it's really a full multi-tenancy provisioner if that's something that you're doing. And again, everybody defines multi-tenancy a little bit differently, but just keep those things in mind, that you don't necessarily have to make it more complex. You can make it easier and define them all by policies that you can, version and get alongside your other Kyverno policies that do your standard validations and mutations. Mentioned early on that one of the things Kyverno has done for a while, actually, it was one of the first engines that could do image verification without needing any other bolt-on components. So the flow looks a little bit like this, where you define a policy. The policy says which images that you want to check. It has things like your key, other annotations, and this is all, by the way, using SigStore cosign. So Kyverno is looking to add support for Notary v2 in the next version, but right now SigStore cosign is what we're currently using. So depending on how you use cosign to sign your images, you codify that in a policy, and then whenever that image gets built through a trigger, that will get signed and pushed to the OCI registry. You can do things like attest to images and also have those stored in addition to your signatures. And then when that image gets pulled down, because that Kyverno policy exists in your cluster, then the policy will be able to validate the things that are inside of that, whether that's an image signature, any of these attestations, before that's allowed to run. So this is a little bit more of the signing and verification that Kyverno can do. And here's an example of what that may look like. Now, there's obviously a lot of stuff going on in here, but very simply, this checks for provenance. So you may be doing this now. If not, you may be doing it later, which is to create a provenance for every image that you're building, so that you can know who created it, when was it created, what were the circumstances around its creation, checking for a software bill of materials, and then doing things like checking for a vulnerability scan. But that vulnerability scan has additional constraints that are around it. It needs to be created by a scanner that you run and control. It needs to be no older than 24 hours, because you don't want somebody to be able to, denial of service you accessing a scan. And that scan actually has to have no high or critical vulnerabilities. All of these things are codified in this one policy as YAML. And you can see under the attestations, these are the predicates that we're checking that correspond to each one of these. And these are the conditions for the image check. And again, standard Kubernetes expressions, tripartite expressions, no code anywhere in here. And in this case, we're checking this, any images that come from this repo are going to be checked. Kyverno uses the upstream Kubernetes policy working group PolicyReport CRD. This is an open standard that many tools are open to implement, and several of them do. Kyverno, to my knowledge, is the only policy engine that uses this open reporting standard. But what this allows you to do is have Kyverno generate what are called policy reports inside of the Kubernetes cluster that have the results of things like validation and those image verification policies. So what you can do when you have a policy that's reporting on those, whatever the require labels that I showed earlier on, you'll get something like this. kube control get policy report across all namespaces, it'll tell you all of the things that are corresponding to that policy, how many pass, how many fail, so on and so forth. And here's just an example of what the snippet of that policy report would look like for an entry that fails. So you can see here, I've got a pod out in the default namespace called BusyBox, and it failed my rule called check for labels, and there's the message that returned. So messages can be templated with variables, and if you wanted to, then the message would show, that the results of that templating. So an open standard that allows Kyverno policies to be deployed initially in transparent mode, so it won't impact anything. You can go and see the results of what policies that you're interested in before you flip them to enforce mode. This is great for you folks that are looking to help developers to the correct path without just slamming the door shut on them on day one. Runs completely transparent. And the policy reporter, which is an open source component, is able to pick these up and display them in a graphical format with a bunch of other things that are around it. So this is a little bit about policy reports. The Kyverno CLI helps really two personae. Policy authors, you can test policies locally against a resource that you have or against an active cluster without installing Kyverno in that, just to see what's going to happen, so that you can evaluate policies against your actual resources without having to yank all of the resources out and put them in a file. And also users, you can validate their, those users can validate their own resources even before they submit a PR if they want to. And obviously, like we showed earlier, if you're using this in the pipeline, then you want to do that on commits and PRs and things like that, so that you're doing the same thing. Another thing to add, another change that was in 1.9 brings experimental support for OCI artifacts. So you can store Kyverno policies in your OCI registry as a native OCI artifact. Later on in future versions, we're going to enhance Kyverno so that you can do things like fetch them from the engine itself. But today we have the beginnings of allowing the CLI to push and pull those things from a registry for you. So Kyverno has full instrumentation with open telemetry with a bunch of metrics that are out there. There's a dashboard that ships inside of the Helm chart. It's optional. There's a policy reporter component, which picks up on metrics as well. I'm not going to go through all of the available metrics. They're documented. There are more that are introduced with every version. And from the visibility standpoint, another new thing that was added in 1.9 is distributed tracing. If you're using things like Tempo or Jaeger or whatever, Kyverno is fully instrumented with distributed tracing. So you can send those spans to your collection engine and see everything that Kyverno does internally for every resource, which is great for troubleshooting. It's also great for auditing.